Hi, I'm Leo, and today we are going to see a workflow that enables us to drive at the job level from within Movie Render Queue specific values from any actor that you like, be it a specific actor in the scene or a post-process volume or any kind of logic that you can do in blueprints without any code and without any plugins. When you render a scene with Movie Render Queue, you want maximum settings. So if you check in the Movie Render Queue settings, you can add the game override section and check the settings available there, but everything under game overrides is always activated unless specified otherwise. You can also check under console variable settings, and there you can add specific per shot overrides. You can, for example, add an entry and search for ray tracing culling, for example, set to 0. You can also see the tooltips here. Or you can set, let's say, motion blur separable to 1. And these settings can be set per job. You can also add some custom events inside the console variable settings. We can actually pass a console command that will get an event by name and try to run it on every actor in the level. So there's actually a very good tutorial about this by Shaun. So I'm gonna show you first how this works. Let's create a new blueprint class of type actor. Let's call it BP tutorial. In the event graph, let's right click and search for custom event. Add custom event. Let's call this my event. And with my event, let's first check the call-in editor boolean here so we can debug this more easily. And let's drag from my event and get all actors of class. And let's try with something very obvious. So we'll select static mesh actor. And then with each static mesh actor, let's do it for each. We'll change the material. So we have a static mesh actor reference. So set material on the static mesh component here. Up, and let's plug this in the loop and let's select a very obvious material, something like this. Okay, and now let's add several cubes in my scene. Let's also drag and drop the blueprint in the scene. And here in the details, we can see that my event is now exposed to the editor. Let's simulate the scene and let's try to run the event. Here, my event. We can see that the event ran and every static mesh in the scene turned pink. So let's stop the game. Everything is back to normal. And now is the part you don't know about. If we simulate again, and we go to the console command on the bottom left, and we type something very specific, KE space multiply sign space, and then the name of your event. So my event, and press enter. Then we can see here called my event on everything in the world and one instance is succeeded. So this KE syntax actually triggered the BP tutorial to run its event. Now we'll try to run this logic inside a Movie Render Queue job. For this, let's create right-click new level sequence. I'm gonna open it and click this button to add immediately a camera. And now that we have something good enough, we can click this button to send the sequence to Movie Render Queue. Let's go into the settings and add setting of type console variable. Now, under the start console command, let's click the plus to add an entry. And now, let's type KE space multiply sign and then the name of your event. So for us, it's my event. Let's click accept, then render. And we can see that everything is pink. So these two ways of adding extra settings are very cool, but they have some limitation. With the console variables, you can only tweak settings that are already exposed to console variables, obviously. And with the second option to run custom events, you cannot pass input variables. You cannot pass values to it. You can only choose to run or not to run an event. So what I'm going to show you today is a new method of controlling your renders and passing some variables to run custom logic. The idea here is to use Data-Driven CVars. It's a native feature of the engine, and it allows you to create custom console variables. We will then create a custom blueprint actor that will read the values of these custom console variables and run some logic on any actor in our scene based on the values we input. The last step is to expose these custom console variables to our movie render queue job preset. So let's go. First, we need to go inside Edit, Project Settings, and type Data-Driven CVars. And you will see that this section comes up, and you have the option to add an element to the CVar array. So let's do it. And if we open this menu, we can see that we have a new CVar type, and we can choose several options. First one is the type of our new CVar, and we have the choice between float, integer, and boolean. So let's go with an int for now, and a name, and then it's up to you to choose a name that's different enough from the basic CVars from the engine, and something that you would remember. I'm using most of the time something that starts with cine dot, because it's used for like cine rendering, but it can be my CVar dot something or anything you want, really. It's just something that you will need to remember. So let's go with cine dot tutorial. And then the next option is the tooltip. So this is a tutorial CVar. And you also have the option to enter a default value. So now that we have a new entry in our CVar array, let's get back to the editor and check at the bottom from the console command. We can type and check if we have our cine.tutorial console command, and we can see that we have the entry here in the subsystem. We have the current value that is 0, and the tooltip appears too, and we can change its value, and it appears in the output log. So now, what do we do with the new CVar? Well, what we are able to do is to create, let's create a new tutorial folder and create a new blueprint actor. Let's call it BP tutorial. So what we are going to do is to create an actor that will check the value of the console variable. So let's go into the event graph. For now, let's use begin play, and we will need to search for console variable. So if you type console, you get these different nodes: get console variable bool, float, string, or int value. And we will need to select the integer value because we created earlier an integer variable. This node just needs to get the name of the variable we need to retrieve. So I think it was cine.tutorial, like this. For now, let's try to print it. So print string, and send this value to a print string. And we will create a custom event called print. I enable call in editor here just to show you. So now, if we run this event, we will print the value of our custom CVar. I'm gonna compile, save, minimize this, and just put my blueprint actor inside the level. Because I enabled the calling editor feature of the event, I now have the option to use it there, and I can click on it, and I printed the value 1, which I think was the value we set earlier. If I now change the value of my cine.tutorial, something like 25, and I run the print again, now it's 25, so I can read the value from my blueprint. So now that we have some basic console variable, let's see how we can use it at render time to drive some logic. I actually have an actor here, which is a blueprint with a special material on it, and it has a value variable that if I change the actual value, it will get printed on the cube. So if I enter manually from the editor, we can see that the cube changes, and we will try to change it at render time. Let me just show you what's inside the blueprint. So it starts at begin play, and then waits a bit. I'll explain this part later. Get the value of our scene.tutorial variable, and then simply passes it to a material instance dynamic that's then printed on the cube. So let's set it to 0 for now at black. And now we will create a specific render cube preset and change the value from there. Let's open a level sequence, and let's send the level sequence to movie render queue with this button right there. I'm going to click on the config. So inside the movie render queue config, we have the option to add a console variable setting. And from there, under console variable, let's search for our cine.tutorial and enter some value. Let's go with 5. Then I will hit render, and you will see that the value from the configuration has been passed to my blueprint. Now that was for movie render queue, but if you're using movie render graph, it gets even a bit better. Let's switch from the drop-down menu here to movie render graph, and let's create a new movie render graph asset. Let's call it tutorial. If I click there, we will open the render graph and make some room, and here on the global exec line branch, let's add a node. We'll search for console again, and we can see the option to set console variable. This is the equivalent of the console variable settings we had in movie render queue. So let's in the details panel enable the name line and search once again for cine.tutorial. And then we can see that the value is here for us to enter, but there's something better to do. We can right click on the node and then search for expose property as pin. And then we are going to expose this value to a pin there. And with this pin, we can right click again and promote to variable. And this will create a variable here on the left inside the graph that we will see in the job, in the movie render queue panel. So actually I forgot to plug this sec pin. Let's close it for now. And we can see here that we have a new line under scene.tutorial. Let's try with the value of 0, so we get a black cube. And if we try with a value of like 5, we get a 5. So everything's working. So now you can see that it's very easy to, for example, run twice the sequence with different values, or to drive something more interesting. So let's see what we could drive. So I created a little scene here with a simple sphere casting shadow that's from a rect light here. and the right light is quite large. And what we are going to look at is the area between the dark shadows and the direct lighting. And you may be able to see it with the compression, but this area can get pretty noisy around here. And this is due to the fact that this light is casting ray trace shadows. And this is just the way it works with the base settings. So what can we do to mitigate this issue? Actually, if we click on the lights and we search for samples, we will see under ray tracing the samples per pixel. So this is the quality of the light, basically, of the shadows, basically. This is the number of samples that get cast by the light to mitigate this. The noise is due to the fact that Unreal has not enough data to get something smooth and consistent. So right now, the value is at 1. That's the default value. And if I raise it to something like 4 or even 16, you may be able to see that the gradient is now smooth. We just see some lines because I'm running an 8-bit monitor right now. But if I switch from 1 to 16, I'm hoping you will see the difference. So the idea is that we could put 16 samples on every light inside one level, but it will start to get expensive, and you in editor, while you're doing your scenes and whatever, you may have a harder time rendering the scene. It will be harder on the GPU. So what if we could use one sample all the time, and when we want to render, we switch every light to 16, for example? Well, this is exactly the kind of issue we can resolve with this workflow. So let's write something for it. So inside my tutorial blueprint, let's get rid of not everything of this print, and instead of printing the value, let's get all actors of class, for example, and we'll select rect light. Here you could run any kind of logic you want. You can run this on every light in the level, every rect light. You can tag some actors and get actors with tag. It's up to you, really. Since I already have a rect light reference, I can search for set samples. And now we can see that I have a set samples per pixel on my rect light component. Up. And now we only need to plug the CVar value from here to here. And we have something that's already like a complete logic. Now, the only thing that's left to decide if do you want it to run every time at every render time. For this, we can use the begin play, but I found out that between begin play and the render start from movie render queue, there's a slight delay. That means that our custom CVar is not, the value has not been set at begin play. So if we were to run this logic like this fires too early in the render process. So the value is still not the correct one. So we can just wait a bit, and we are going to use delay until next tick. And I found out that you need to use it twice. So I'm just duplicating this here before getting the value. And if you do it like this, begin play, and then waiting for MRQ, let's say render start, so that this value has been set by the job. The other option is that we could use another custom event. So let's right click custom event and call it get CVars, for example. And then we would trigger this event inside the job directly. Let me show you. I'm going to get back to the movie render queue here. So let's start first with the movie render queue, the old one. And here in the same console variable settings, we can add the start console command. And as we saw earlier from the Shaun tutorial and the blueprint event method, we can enter KE, then this symbol, multiply, not sure of the name, and then the name of our event that was get cine CVars. And this will trigger the event at the same time that we set our custom CVar here. So when this fires, this value has already been set. So we are sure that the timing is right. If we were to use the movie render graph instead, so let's go back to movie render graph and use our tutorial graph. So if you right click, type console, you can find the set console command, set start console command. And here you have the add start command. And you can enter from the syntax KE multiply get cine CVars. And now if we plug it correctly, this is the equivalent of the movie render queue. Okay, now let's add another setting to this workflow. I'm going to add a new console variable, add a new line in my blueprint to control something in my post-process volume. So let's go back to the project settings and let's add a new data-driven CVar. This will be a float this time, and I'm going to call it cine dot so that the naming is consistent. Lumen final gather. And you guessed it, we will drive the Lumen final gather from the post-process volume. Okay, now let's go back to our blueprint. And here we got the first variable, and then we did some logic. So let's add here, let's make some room, Control Alt left click and type sequence so we can visually space out the rect light logic and the new logic that we are going to add just below. So we need to get our new console variable. So get console variable float value. It's called cine dot lumen now gather. Then we will get, I'm gonna use get actor of class here because this node only return one actor, and I know that in my level I'm gonna use only one post-process volume. Otherwise you could just get use a tag or something and use the get actor. If you type get actor tag, you can get all actor with tag or get all actors of class with tag. And let's type post-process volume. So now I'm getting the first post-process volume in my level. And from there, I want to change a specific settings, but not touch anything else. So for this, we need to first get settings there. And from these settings, we need to set members in post-process settings. And this node allows us to expose as a pin whatever settings you want to change. So let's search for Lumen Final Gather. So this is the first one. And now I have just one pin. And with the output, I can use my post-process actor reference. And instead of get settings, I will set settings there. And now I plug the output of my set members into the set. So the idea is that we get all the settings and we only change one settings and we set the settings afterwards. Like this. And now it's the same as earlier. We need to get the value from the CVar and plug it into our logic. So let's make some room for this. Okay. Okay, I think that's all there is to it. I'm going to go back to my graph and let's add another set console variable node. Let's move this to the right and search for console, set console variable. And the console variable name is going to be cine.lumen final gather, okay? Same thing as earlier, right click value, right click promote to variable, and now we get cine.lumen final gather. I'm going to rename it, and that's it. Let's save. And if we get our tutorial job here, we can see that we have a Lumen final gather input here. One thing I forgot is that it would be a good idea to use a default value of the new variable there. Let's use 4. Up, if we go back, we need to reload this. We have a default value for Lumen final gather of 4. So you don't need to worry about whatever settings you have in your scene. You will always get max quality. Now I'm just going to show you a simple way to add an on-off toggle for this logic we just wrote inside the graph. So I'm going to open the graph once again. And this is the part that we'd like to have an option for this. So let's do from the end of the branch of the branch, let's do a node called branch. And if true, let's run this. If false, let's get back to the first node before our logic. Let's make it a bit clearer like this. Okay. Let's go back to global so we finish the exec branch and just right click to the branch, promote to variable. It's hidden there. And this is a new Boolean variable under the graph called use cine CVars, for example. You can type whatever description you want there, and let's have a default value of true. I'm going to save, and then you have here the option to use cine CVars or not. I find this method very useful because with every new level that you want to render, you don't have to check every actor for settings. You know that your base rendering settings are being grabbed from the movie render graph asset, and you can get every variable you want in a very contained window right when you need it at render time. Okay, so that was it. Thanks for watching, and I hope you find this useful.